Good morning, friends. This is one lecture which is related to UV Visible Spectroscopy. We have learned about some instrumentation uh, related to UV Visible Spectroscopy, especially colorimeter. Now, in the last lecture, we have taken wavelength selector such as prism. We have studied about the prism. Now, in this lecture, we have studied the diffraction grating. We in the last one, and this is one lecture where I will focus on this filter acts as a wavelength selector. Now, diffraction grating is also the one part of uh, filter, or it is a wavelength selector. So we will go through it. It is mostly used as a monochromator in highly sophisticated instrument. Diffraction grating is a one type of sophisticated monochromator. It works on the principle of diffraction of electromagnetic radiation. Now, what is the principle of electromagnetic radiation? What is the principle of diffraction grating? It is a diffraction of electromagnetic radiation. So, diffraction grating works on the principle of diffraction of electromagnetic radiation. So, the incident radiations which come out from the source when strike the surface of diffraction grating, at that time diffraction of radiation takes place. Now, what is diffraction grating? This is the second paragraph. It consists of number of parallel and closed spaced grooves of proper shape. So grooves of zigzag shapes generally. Now these should be the parallel and closely spaced. The quality of grating depends on the degree of precision with which the straightness, the parallelism, and the equidistance of grooves are controlled. Now, if you see, this is we can say the diagram of diffraction grating, and the parallelism and equidistant nature should be in a high precision manner. A grating typically contains 300 to 2000 grooves per mm in ultraviolet and visible region, out of which 1200 to 1400 are most common. Now, generally, on the surface of grating, number of grooves are present. They vary from 300 to 1200 per millimeter, but out of which 1200 to 1400 are most common. So these are utilized in ultraviolet and visible region. So these are all about the diffraction grating. Now, how diffraction gratings are prepared? That is nothing but this paragraph. Preparation of a good quality grating is very difficult. Now, good quality diffraction grating is obtained. That is not possible. Mostly, duplication grating is obtained from master grating. Now, master grating is utilized for the preparation of duplication grating. Master grating is coated with polymeric material such as resins. The resins are utilized to coat the master grating, and it is allowed to set. It occupies the shape of grating. It is removed carefully from master grating. Thin film of aluminum is deposited on it. So aluminum is deposited on the surface of master duplication grating. It is fixed on glass plate to give the mechanical support. So glass plate is utilized to adhere to give the mechanical support. Each groove, so there are 1200 to 1400 grooves per millimeter. Now each groove consists of a broad face which is exposed to electromagnetic radiation. Among that groove has a broad face and which is utilized to capture the electromagnetic radiation. The distance between the grooves is adjusted equal to the wavelength of electromagnetic to be selected. So it is very important sentence. The distance between the grooves is adjusted in such a way that should be the wavelength of electromagnetic radiation. That should be the wavelength of electromagnetic radiation. If 650 nanometer is selected to measure for the measurement, then the distance between the grooves is also the 650 millimeter. So this is a typical diagram of you can say diffraction grating principle. Here light is incident on the surface of grooves. This is the surface of groove. Diffraction grating. Now this is the one type of groove, well, we can say zigzag shape. This is the distance between this D indicates the path difference. This is the distance between these two adjacent grooves. Now I is there and R is there. I indicates the incident radiation, R indicates the reflected radiation or refracted radiations from the surface. So this ratio is nothing but the part difference, and that part difference is given by the n lambda according to formula. N lambda is equal to path difference is equal to D into sine angle of incident radiation minus sine angle of reflection or reflection radiation. So D into sine I minus sine R. So that is nothing but the, you can say, formula. That is nothing but the, you can say, the formula that will be useful to measure the absorption measurement, that should be useful in absorption measurement. When a polychromatic beam of electromagnetic radiation is allowed to pass on grating, above equation satisfy the only for a single wavelength at one time. So single wavelength is only useful to carry out the equations or solvations, or you can say solutions. When polychromatic beam of electromagnetic radiation is allowed to pass on grating, above equation satisfy only for a single wavelength at a one time. So this depends on the wavefront also and interference input obtained from the grooves. So different types of diffraction gratings are there. Echelli grating, first is Echelli grating, second is a concave grating, third one is holographic grating. So three types of the gratings are useful. To obtain the any type of grating is useful to measure the measurement in absorption spectrophotometers. Now the disadvantage, what is the disadvantage of grating? Diffraction grating has a disadvantage. It gives the first order diffraction along with second and third order diffraction, which is not expected. Now here the prism has a advantage that it gives only a first order diffraction, but here opposite to that diffraction grating has a disadvantage. It gives a first order diffraction along with a second and third order diffraction, which is not expected. What is the advantage of diffraction grating? It gives rise to the overlap of wavelength. So overlap of wavelength is nothing but it is a disadvantage of prism. Now which is the advantage of the diffraction grating? So that is nothing but the opposite pattern of advantage and disadvantage of prism and diffraction grating. So remember all this point regarding the diffraction grating. So this is nothing but the all about the diffraction grating, the principle of diffraction grating, working of the diffraction grating, how it is obtained from the master grating, what is the equation on which it is lies, what is the principle of diffraction grating, and what is the disadvantage and advantage of diffraction grating. So with this content I conclude this lecture. Thank you very much for patience listening.